Okay, here's the last lab for the controller proposal. And for this last lab, we have 6 specifications. The first one is 0 steady state error. Then is only 2% overshoot. Power usage less than 24 volts. Race time less than 0.1 seconds. Steady time less than 0.2 seconds. And the last one is have a small initial slope. So in order to determine the possible controller, that we decide 4 different kinds of the controller. The first one is proportional, is the most easy one. It just a linear proportion to the input, then gets the output. But the thing is, this cannot meet the error specification with a high voltage, high gain, or may now or maybe cannot use high gain without requiring large voltage. And the second one is a PD controller. This one has a short steering time, but this may cause a high overshoot. Also could increase the noise and error. So this may not meet the error specification without a very high voltage. The third one is the PI controller. These things may increase the steering time, but this one may reduce the error to 0 in the long term. The last one is PID controller. This one combines the PI and the PD controller's advantage. So this has a fast responding time, but the cost has a high overshot, may got a voltage output, and also may increase the noise.
So because of the design specifications that we had to narrow it down to just the proportional integral controller and the proportional integral derivative controller, mostly because of the 0 steady state error. None of the other controllers could do that. And so we finally decided to use the proportional integral controller because it's a little simpler to calculate and it met our specifications the best, because the PI controller can easily do 0 error because of the integrator, and it has low overshoot and output voltage. But in order to meet the settling time specification, we had to increase the gain. And then because of the high gain, we also had to add a filter to decrease the overshoot and the high voltage output.
Controllers don't have to just, or the plant that we're controlling doesn't just have to be voltage to disk speed or disk angle. Other things that we can try to control, as long as we have an input and an output that are that can be modeled either through physics modeling or experimentation, we can make a plant for any process, whether it be pedal position to throttle position, the burning of fuel vapor ignition, and its effect on cylinder pressure, and then that's effect on engine torque. The heat generated by a flame to change the height for a hot air balloon, or a signal transmission to change the angle for a gyro in a satellite, or a constantly changing pitch angle to maintain a solar panel to have maximum efficiency facing the sun or whichever direction it needs to for energy generation. The design process is to experimentally check for the relationship between the input and output, either using experiments, physical modeling, or whatever, to find the plant. If this plant has a reliable output that can be modeled to create a transfer function, and this transfer function can be modified using a controller, the input to to this plant can modify the output to meet desired specifications or outcomes. Thank you.